Okay, Assalamualaikum and good day. We meet again in the new topic. Okay, we are starting the logic topic. Okay, these are all the subtopic that we are going to cover. Okay, first of all, we are going to have an introduction of the fuzzy thinking. We go back to the history and some definition of what we mean by fuzzy logic. Then we start to define, understand what is a fuzzy set. Uh, we are going to convert, actually, not to convert, to identify the linguistic variable and ages. And then operation of the fuzzy set, fuzzy rules, and then we conclude. So, what is fuzzy thinking? As we know that experts normally rely on common sense when they solve the problems based on their common sense. How can we represent this expert knowledge that use vague and ambiguous terms in the computer? We want to apply it in the computer. How we want to get the expert knowledge from the expert in order to, and this knowledge actually vague and ambiguous. We want to put it in terms in the computer, terms of the computer. As we know that sometimes when we think the terms fuzzy logic, actually is not the logic that is fuzzy, but the logic that is used to describe the fuzziness. We use a logic in order to describe the fuzziness. Fuzzy logic is a theory of a fuzzy sets that calibrate the vagueness. A fuzzy logic is based on the idea that all things emit on degrees. Everything, every thing that we can measure, it emits certain degrees. For example, like temperature, height, speed, distance, beauty, all come on a sliding scale. You can have a continuous sliding scale. For example, the motor is running really hot. Really hot. What do you identify the really hot? You can put it in states. The Tom is very tall guy. Also tall guy, we can put into a scale. Okay, in Boolean logic, it use sharp distinctions. It doesn't have any value. Okay. It forces us to draw lines between members of a class and non-members. If you have a class, after you make a classification, you can draw a line. And this line is a straight line where you can identify it between members and non-members. For instances, we may say Tom is tall because his height is 181 centimeters. So if you drew a line at 180 centimeters, then you would find that David is 179 centimeter is considered as small, actually short. Do you think that David really a small man in 179? Since you make you draw already a line less than 180, we consider it small. Or we just draw an arbitrary line in the sand. This is we need to think of. Fuzzy logic reflects how people think. They try to mimic how the people think. It attempts to model our sense of word, our decision making, and our common sense. Where, as a result, it is leading to a new, which is more human intelligence system. We are going to create uh, uh, ideology is trying to create in a machine environment which is more human. Thinking of giving solution in more human way. Okay, fuzzy or multi-value logic was introduced. Okay, this is the history in the 1980s by Jan Lucas Rich. Actually, in the beginning it's quite not clear yet, okay? Which is a Polish philosopher. Okay, while classical logic operate only with two values, you have true or false. Where this guy, Lucas Smith, introduced that logic that extend the range of true values to a real number in the interval between 0 and 1, where he used a number in this interval to represent the possibility that a given statement either is true or false. Okay, for example, possibility that a man 181 centimeter tall is really tall might be set to a value 0.86 tall. So it is likely that the man is tall. So this would lead to the inexact reasoning technique, which often called as uh, possibility theory. Okay, this is the beginning of the fuzzy logic. And then next, at 1937, in this era also, they are not clear yet about the fuzzy, how we want to establish it. In a machine, we want to put in a machine. The Max Black published a paper called Vagueness and Exercise in Logical Analysis. In this paper, he argued that continuum implies degrees. Okay, which imagine, he said, a line of countless chairs. At one end in Chippendale, next to it is near Chippendale. In fact, indistinguishable from the first item. The succeeding chair are less and less chair-like until the line ends with a lock. When does a chair become a lock? So where actually the statement of the Next, Black accepted vagueness as a matter of probability. It is lead to the fuzzy logic. Yeah, this is the one that we can call as fuzzy father of the fuzzy logic, which in 1965 Lotfi Zadeh, which published a paper where it called as a fuzzy set, where Zadeh extended the work on possibility theory into a formal system of mathematical logic and introduced a new concept for applying a natural language terms. It applied to the natural language. This new logic for representing and manipulating fuzzy terms was called the fuzzy logic. So Zadeh became master of fuzzy logic. So he is actually the father of the fuzzy logic. Okay, why fuzzy? As Zadeh said, term is concrete, immediate, and descriptive. We all know what it means. Okay, when we mention about fuzzy, we all know what it means. However, many people in the West were repelled by the word fuzzy because it is usually used in a negative sense. Okay, when we mention about fuzzy, sounds like negative, a negative impression. And why we call it logic? Fuzziness said, fuzziness actually rests on the fuzzy set theory, and fuzzy logic is just a small part of that theory. Okay, so in conclusion, what we can define it, fuzzy logic is a set of mathematical principles or knowledge representation based on the degree of membership. It is a mathematical principle which we want to represent the knowledge which is based on the membership. Where in Boolean, okay, two value Boolean, 0 and 1, Boolean logic. Fuzzy logic is multi-value. Okay, we can have a number of membership, number of value. It deals with degrees of membership and degrees of truth. Okay, fuzzy logic uses the continuum of logical value between 0, which which is completely false, and 1, which is completely true. Instead of just black and white, it employs the spectrum of color, where accepting the things that can be partly true and partly false at the same time. If you look, this is the difference between the Boolean logic and the multi-level, multi-value logic. Where in Boolean logic, you only have two values, 0 or 1, and white or black, true or false. Where in the multi-value logic, you have a spectrum of color here, from totally white until totally black, where can be assigned to a particular numbers, numerical number between 0 and 1. Okay. What is fuzzy set? It is a concept of a set. The concept of a set actually is fundamental to mathematics. However, our own language is also the supreme expression of sense. For example, when we mention about car, indicate sets of cars. When we say a car, we mean that one out of the set of the cars. In the classical example, in fuzzy set is a tall man. Okay, this is what we discussed previously. We have mentioned it about tall man. The element of fuzzy set is tall man. Elements of the fuzzy set is tall men. Are all men. Tall men are all men. But their degrees of membership depends on their height. How do we put in the uh, degree of membership? For example, we have a name here, and then we have their heights, and then we have a degree of membership. So there are two degrees of membership. Either we have creeps or we have fuzzy. Creeps, as we discussed before this, we have only one. Either it is true or false, zero. As we draw a line, if you less than 180, we consider you are false or the consider as a tall man. Where if you are 180 above, consider you are tall man. But in fuzzy, you can define individually by number, and it is not just either true or false. It might be partially true or partially false. For example, Chris 208, the fuzzy, the degree of membership for fuzzy is 1. For Tom, okay, Tom before this is 181. Actually, it is a 0.82 to be considered as a tall man. Then we have Mike, for example, David, which is uh, 179. But in Greek, we consider not tall. It is false to be considered as tall. Where in fuzzy, we still put it at 0.78 to be considered as a tall man, and so on. If we can look at the diagram, um, this is a crypt set, where this is a fuzzy set, degree of memberships. This is a degree of membership on the y-axis, and we have a height where we put it in the x-axis. If you look here in the clips, until we have drawn a line at 180 centimeter between the not tall and tall man. While in fuzzy set, we can draw a line. It depends on what kind of curve you have. The x-axis represent the universe of cos. What is the universe of cos? It's actually the range of all possible values applicable to a chosen variable. The variable here is the height. You have a possible value of height. So in our case, the variable is the man height. According to this representation, the universe of man's height consists of all tall men. The universe of man's height consists of all tall men. While in y-axis actually it represent the membership value of the fuzzy set. Okay. In our case, the fuzzy set of a tall man maps high value into corresponding membership value. It is in y axis representation. A fuzzy set is a set with fuzzy boundaries. We don't have a like a creeps, only a straight line. But in the fuzzy set, it depends on how you set. Okay, where set with a fuzzy boundaries. Okay, let X, okay, X, as we discussed before, be the universe of this box, and its element denoted as X, small x. So in the classical set of theory, okay, Gibbs set A of X is defined as function f Ax, or the characteristic of a function A. We define it as it is a function x, either 0 and 1, where and it is 1 is subset of A, so it 0 is subset of not subset of A. Okay, where this set maps universe X to a set of two elements, you have only two elements. For any element X of the universe X, X. Characteristic of the function is equal to 1 if the element is set A, and equal to 0 if element is if the X is not within the element A. Okay, in the previous example, so if you have what if you have the measurement of height is 100 and above, it means that it is an element of set A, okay, where the function, the result of the function is 1. If you have less than 180, okay, which the function is 0, where x is in the scripts membership. But in fuzzy, a fuzzy set of universe X is defined by this function called the membership function of set A, where you have a membership function of set A. It can range between 0 and 1 in range. X can be ranged between 0 and 1. If the function will become 1 if X is totally in A, and it becomes 0 if it's not in A, but it also be in terms of value, value, the numerical value 0 and 1, okay, 0 and 1, if X is partially in A, in A. Okay, where if you look at this function, it allows a continuum of possible choices, wherein for any element of X of universe X, membership function, okay, equal to the degree which X is an element of set A, and this degree of value which is between 0 and 1 represent the degree of membership, also called membership value of the element X in set A. Now we continue how we are going to represent this fuzzy set in the computer. Okay, first we need to determine the membership function. In our example, we use a tall man. We can obtain fuzzy set of a tall man and a tall, short, and average man. This is how we set first. Okay, fuzzy set where the universe of disclose the man's height, which consists of three sets, three fuzzy set. We have short, average, and tall man. Okay, this actually refer to the graph next, the next in the slide. Okay, if you look back, okay, as you will see that a man who is 184 centimeter tall is a member of an average man set with a degree of membership of 0.1. Okay. Later we are going to look at 184 centimeter tall, where at the same time also he is also a member of the tall man which set with a degree of membership at 0.4. Okay, look at 184 centimeter. Okay, this is the creeps. We use the creeps. We have a straight line, both of the fuzzy set of short, average, and tall. Here we have a straight line. Uh, and then we have a fuzzy set, okay, where we draw a line here. Okay, if you look at 184, this is 184. So in 100, if the man is 184 centimeter height, it will have a, if you look the line of average here, it is 0.1. Okay, this is a 0.1 here of the average. So, while it is a 0.4, is 0.4 in the fuzzy set of okay, we don't have in the grid set. In grid set, we only have at 0. Sorry, at 184, it is considered as tall. Okay, so in short, if we look for 184, short is 0. It is not in degree of membership for a short fuzzy set. Okay, now we represent the crisp and fuzzy subsets. Okay, this is in creep. Okay, we have X, height of tall. We have a fuzzy subset and then a crisp subset of A. It is how we represent it. Alright, typical function that can be used to represent a fuzzy set are you can use either sigmoid, Gaussian, or pi, where however this function increase the time of the computation. Okay, if you use this function to represent a fuzzy set, then it's going to take time and space for computation. So normally in practice, most applications use a linear fit function. Okay, as previous you can see in the previous diagram, we just use the linear fit function. Okay, now we define what we mean by linguistic variable and hedges. Okay, at the root of fuzzy set theory, okay, lies the idea of linguistic variable. Okay, a linguistic variable is a fuzzy variable. Okay, for example, the statement John is tall implies that linguistic variable John takes the linguistic value tall. Okay, John is a variable and the value is a tall. In fuzzy expert system, linguistic variable are used in fuzzy rules. Okay, as we look in the example, a fuzzy linguistic variable, if wind is strong, then sailing is good. This is the linguistic variable. Wind, sailing. We can have project duration is long, then the completion risk is high. The other example, if the speed is slow, then the stopping distance is short. Okay, these are all the linguistic variables that we can use. Okay, the range of possible value of a linguistic variable represent the universe of discourse of that variable. Okay, for example, the universe of discourse of the linguistic variables, it might have the range between 0 to 222 kilometers per hour. So, and may include such fuzzy subset as you can put the set as very slow, slow, medium, fast, and very fast. So a linguistic variable carries with it the concept of fuzzy stack qualifier that we call hedges. Okay, where hedges are the terms that modify the shape of fuzzy set. They include adverbs such as very, somewhat, quite, more, or less, and slightly. You get a very slow, medium, fast, that what we call as okay, now we look at fuzzy set with the hedge very. Okay. We have very slow. This is is close of membership. This is a degree of membership. Okay, we can have a very slow. This is an example of the speed of the car and the stopping distance. Okay, this is height. It's not height. It's actually the speed. We have 180, 110. Sorry. This is example of tall. I'm so sorry. Tall. A man, fuzzy set of short, average and tall. Okay, we have a very short, we have a average, we have a very tall. Okay, this is example of H with very. Okay, you can define. Okay, in this line we consider as a very tall. This line is very short. We also have a short and tall. Representation of hedges in fuzzy logic. Okay, how we can represent hedges in fuzzy logic. Okay, uh, this is example of hedge. You can have a little or slightly, or very or extremely. In this you can define. You can have this uh, linguistic variable, and this is the mathematical expression, and these are the graphical representation. Okay, you can have very, you can slide, okay. So you have a little, slide, very, and we have a string, a string. Okay, representation of hedges in fuzzy logic. These are all the examples that you can use. Very also more or less. We can have the other way of shape, for example, somewhat or indeed. These are all the graphical representation, and these are mathematical expression. You can use, maybe you are not using all of it, but this is one, this is the example which you can choose. Okay, now we look at the operation of fuzzy set. Okay, the classical set theory developed in the late 19th century by George Cantor described how creep set can interact. These interactions are called operations. This is a Cantor set. We have not A and B complement in containment. We have A, B set, and then intersection, and then we have union. Okay, complement. Okay, in group set, who does not belong to the set? While in fuzzy set, how much do elements not belong to the set? As we know, clips we just draw a direct single line. So the way that uh, we put it is who does not belong to the set. While in fuzzy set, we can uh, measure it by how much do elements not belong to the set. It is as a complement of a set if an opposite of this set. Okay, for example, if you have the set of tall men, its complement is not tall men. When we remove the tall man set from the universe of discourse, we obtain the complement. If A is a fuzzy set, so its complement is not A. Complement of A is not A. So we can found it as follow when we put in the mathematical equation. A function of not A is 1 minus function of A. Containment. Containment, the definition, okay, how we put it in brief set, which set belong to which other sets. While in fuzzy, we can define as which set belong to other set. Which set belong to which other set, and the fuzzy is which set belong to other sets. Okay, similar to a Chinese box set can contain other set. The smallest set is called a subset, the one that we have. For example, the set of a tall man contains all tall men. Very tall man is a subset of a tall man. Very tall man. However, tall man is just a subset of the set of men in tall man. So in creep set, all elements of a subset entirely belong to a larger set. In fuzzy set, however, each element can belong less to the subset than to a larger set. Element of the fuzzy subset has smaller membership in it than in the larger set. Part of it. And then we have intersection, where the example, which element belong to both set. Which element belong to both set. While in fuzzy set, we can describe it how much of the element is in both sets. The creep is which, and the fuzzy set is how much. So in the classical set theory, an interaction between two sets contains the element of shared by this set. Okay, in the example, the intersection of the set of a tall man and the set of the fat man is the area where this set overlap. Okay, in this fuzzy set, the element may partly belong to both sets with different membership, different value of membership. A fuzzy intersection is the lower membership in most set of each element. The fuzzy intersection of two fuzzy sets A and B on universe discourse, the discourse of X, we can write here the intersection of A and B, which we select which one is the minimum of function A, function B, X equal to the function A subset of function B where X is subset of X. And then we have union, encrypt set, which element belong to either set, which element belong, and then how much of the element in either set. Okay, these are in union uh, with the examples. Okay, operation of fuzzy set. Okay, we look at the operation of fuzzy set. It is a function. Uh, we have a and then not a complement of it. Okay, this is for containment. And then we have intersection and union. Okay, in fuzzy room, this also actually being published by Zadis, where he has the second most influential paper, where in this paper actually outlined the approach to analysis of the complex system, okay, where it suggests capturing the human knowledge in the fuzzy room. So what is a fuzzy room? A fuzzy room can be defined as condition statement in the form of if X is equal to A, then B is then Y is B. This is the form. This is the structure of the where X and Y are linguistic variable A, X and Y, while A and B are linguistic value determined by fuzzy set. Okay, this value is identified through the fuzzy set on universe of discourse X and Y respectively. So what is the difference between the classical and fuzzy rules? A classical if then rule use a binary logic, for example, rule number one, speed is if speed is larger than 100, then stopping distance is long. Rule number two, if speed is less than 40, then the stopping distance is short. So the variable speed can have any numerical value. So we see between 0 to 0 kilometer per hour. But the linguistic variable stopping distance can take either long or short. Okay, so in other words, classical rules are expression in black and white language of the Boolean. Okay, we can also represent the stopping distance rules in fuzzy in form of if the speed is fast, stopping distance is long. Okay, if you look back uh, where the value of uh, compared to the classicals, the numbers compared to the value of fuzzy. If the speed is low, then the stopping distance is short. So in fuzzy rule, the linguistic variable also has the range where the universe of discourse between 0 and 2.0 kilometer per hour. But this range actually includes the fuzzy set, in which we have slow, medium, and fast. We have a fuzzy set of slow, fuzzy set of medium, and fast. The universe of discourse of the linguistic variable stopping distance can be between 0 and 300 and may include such fuzzy set as short, medium, and distance. Okay, if we have the uh, universe of discourse between 0 and 300, then we can establish the fuzzy set. Okay, fuzzy set of short, medium. Fuzzy rule relate fuzzy set. We need to form a fuzzy set in order to establish the fuzzy rule. In fuzzy system, in fuzzy system, all rules fire to some extent. In other words, that fire partially. If the antecedent is true to some degree of the membership, then the consequent is also true in some degree. Okay, we have a some degree where most of the rule, all of the rule is going to be fired to a certain extent. Okay, if you look at the fuzzy set of the tall man and heavy man here, okay, this is a tall man and heavy man. This fuzzy set provides the basic of a weight estimation model. The model is based on a relationship between a man's height and his weight. Okay, if you look here, uh, this cost of membership, okay, is high in the first for the tall man, and then we have weight for the heavy man. So we can make if height is tall and then we have weight is heavy. Okay, the value of the output of a true membership rate of the rule consequent can be estimated directly from a corresponding true membership rate in the antecedent. In this form of fuzzy inference use the method where we call it monotonic selection. Okay. If you look here, if let's say the man is tall, which is into certain degree, it also uh, weight at certain degree. A fuzzy rule can be multiple antecedents. For example, if you have here, if project duration is long and project staffing is large and project funding is inadequate, then the risk is high. You can have more than antecedent with the consumption value at the end. Okay, if service is excellent or food is delicious, then then tip is generous. Example of having more than one antecedent. The consequence of a fuzzy rule can also include a multiple part of, for instances, in the antecedent. For example, if the temperature is hot, then the hot water is reduced, the cold water is increased. You have two. Here in this example, we have two consequences.